welcome to this episode of Night Sky News for July 2024 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this month's episode, we're chatting all about the intermediate mass black hole that's been found in our galaxy right in the mass gap, where we barely ever find black holes of that mass. We're also chatting about JWST's look at the famous Penguin Galaxy, plus the mini planet Chiron that appears to have turned into a comet. There's chapter markers down here if you want to skip ahead to any of those specific news stories, plus any scientific research papers I mention are all going to be linked in the video description down below, free to read. So without any further ado, let's kick things off and start by looking up. All right, at the end of July and into the beginning of August, I have got so many night sky treats for you. First up, on the morning of Tuesday the 30th of July, the crescent moon, aka my favorite moon, the toenail moon, will be close to Mars in the morning sky just before sunrise. It'll be in the east towards that glow of the rising sun. Now, Mars will have its characteristic reddish glow that you should look out for, but make sure that you don't confuse it for the red star Aldebaran that will be very close just below Mars. Also nearby will be the Pleiades star cluster and the much brighter, whiter Jupiter. And if you missed this on the 30th, don't worry, because on the morning of Wednesday the 31st, the moon will then have moved along its orbit to be closer to Jupiter. Now, the further you are up in the northern hemisphere, obviously the earlier the sun rises for you at the minute, so you are going to have to get up pretty early if you want to see this one, but I think it will be worthwhile because all of Jupiter, Mars, the moon, Pleiades, and Aldebaran will be visible in like a single field of view of binoculars all at once. So you're set for a great sight and some lovely astrophotography opportunities as well. Now, it's not just the 30th and 31st of July that you can see Mars and Jupiter. They should be visible all throughout the next couple of weeks in the morning sky, rising ever earlier as time marches on, and also appearing to get closer and closer together from our perspective as each planet moves along its orbit. So that by early morning on the Thursday, the 15th of August, they'll have gone past what's known as their conjunction. Their closest approach on the sky, where they'll be 0.3 degrees away from each other. That's less than the width of the full moon on the sky, or around about the width of your little finger held out at arm's length in front of you. Meaning they can both fit in the field of view of, like a typical amateur telescope at the same time. Now, wherever you are in the world, you should be able to watch these two getting closer and closer together as the month of August goes on. But the official closest approach that they reach on the sky will happen at 16:52 GMT on Wednesday, the 14th of August. So if in your time zone that ends up being early morning, so probably talking about like New Zealand and Polynesia there, you'll see them at the exact time when they make their official closest approach together. The rest of us will just see them a few hours either earlier or later. They won't have moved that much. We'll still see them very close together. But the main thing I want everyone to watch for this month is meteors, aka shooting stars from what I think is the best meteor shower of the year, the Perseids. The peak this year will be on the night of Sunday the 11th into the morning of Monday the 12th of August, where there'll be around 75 meteors an hour in the darkest of skies in the northern hemisphere. So roughly one meteor or shooting star every minute or so. Now, if you're in the southern hemisphere, roughly half of the meteors will streak below the northern horizon for you. So you won't quite have as good viewing conditions as in the northern hemisphere, but it'll still be pretty good as meteor showers go. Now, remember, the further you can get away from light pollution, the better, because the bright lights of a city give the sky sort of a glow, which means that they wash out the faintest of meteors in the shower so that you only see the brightest of meteors, which means you see less of them every hour. So if you can get to somewhere remote and dark for that weekend on the Friday and Saturday night, you will not regret it. Also, if you look at the moon phases, the moon will be less than a half moon around that time and will set just a few hours after sunset. So the moon also won't be in the way. It won't be brightening the sky like when we have a full moon. So we really do have optimal viewing conditions this year. Now, the Perseids are known for their really bright meteors that last longer than others as well. They're caused when tiny lumps of rock burn up in the atmosphere that come from the debris left behind by the comet Swift-Tuttle on its 133-year orbit around the sun. Now, meteor showers need no equipment to watch. Telescopes and binoculars do not help here. You need to see as much of the sky as possible, but you do need to let your eyes adjust for about 15 to 20 minutes or so that you will start to see fainter stars in the sky, but also fainter meteors when they shoot across the sky. So all you really need is like a blanket just to lie on the ground and look up. And this is a great thing to do with more people. You know, if you have a lot of friends and family that you can gather together, you know, you've got more of you spotting the meteors, and it's just a really fun thing to do, you know, as a group. Especially because you can see the Perseids at a normal time, you know, in the late evening with no early get-ups required. And remember, the Perseids Meteor Shower lasts around about a month, right? 2 weeks either side of that weekend of the 11th and 12th of August. So basically, if you see a meteor or shooting star, you know, in that whole month of August, it's most likely from the Perseids. Then finally, in the early morning of the 21st of August, the full moon will fully occult Saturn. Now, occult comes from the Latin word meaning to hide something, which is exactly what happens here. As the moon moves along its orbit, it will pass in front of Saturn in the background and hide it for a while. Now, because of the angles required to fully block Saturn from our perspective here on Earth, there's only certain parts of the world that this is actually going to be visible from. So you'll be able to see it from South America, across Northern Africa, and into Europe. I'll pop a link in the video description below that gives the time of the occultation for where you are in different locations. But the good thing to do is to watch for a good chunk of time if you have clear skies for it on the night of the 21st of August, because you'll see the two of them approach as the night goes on before Saturn completely disappears behind the moon and then reappears again a short time later. In the UK, that occurs around about 4:30 in the morning, again, depending on your exact location, and then it reappears again about 45 minutes later. If you want to check exact timings for your location, I'd recommend using an app like Stellarium. I like the desktop version for things like this, and I'll just zoom in on Saturn and the moon and just click forward on the time to see what time Saturn will disappear and reappear for me. All right, that's enough of looking up at the night sky. Let's come back down to Earth now and chat about what's been happening in space news in the past month. All right, we have to celebrate the successful very first launch of ESA's new Ariane 6 rocket. It made its inaugural flight from Europe's spaceport in French Guiana at 4 p.m. local time on the 9th of July. Now, this is the next in the generation of Ariane rockets. Remember, Ariane 5 is what launched JWST back in December 2021. And now Ariane 6 will be ESA's new workhorse rocket, but it's got a much more sort of flexible modular design this time, which means that it can launch things to low Earth orbit or out to the far reaches of the solar system, dropping off different payloads at different times. So it means it's a really flexible system. Now, as we've seen recently with SpaceX's Starship, success on the first rocket launch is not guaranteed. So it was great to see that for the Ariane 6, the launch went off without a hitch. And with that success, there's many future planned launches now right up until the end of the decade and beyond, including the Plato telescope in 2026, which will hunt for rocky planets around sun-like stars, and also the Mars sample return mission due for launch in 2027, which, if you remember, is set to go and pick up the rock samples that the Perseverance rover on Mars has collected and return them to Earth. And seriously, if anyone from ESA is watching right now, you need to dub this mission Rendezvous. And the reason is we've already got Perseverance, aka Percy, and Ingenuity, aka Ginny, on the surface of Mars. We need to put another Weasley up there with Rendezvous, aka Ron.
From Weasley.
And then also Ariane 6 is set to launch the LISA space-based gravitational wave detector way out in 2035. So lots of missions and telescopes that you might have heard me talk about on this channel before, all being made possible thanks to ESA's new Ariane 6 rocket. Speaking of exciting future missions, ESA's JUICE mission to Jupiter's icy moons is set to do a flyby of Earth on the 20th of August in the first ever lunar Earth flyby, making it the first ever attempt of any spacecraft of a double gravity assist maneuver. Now, JWST was launched back in April 2023, and through a series of planet flybys of Earth and Venus, it will eventually gain enough energy to make it out to the Jupiter system by July 2031. Now, that might seem quite a roundabout way to get to Jupiter rather than just like sending something on a direct path to intercept it, but to do that, you would need just an unfeasible amount of fuel that would be too heavy to launch on the Earth. Plus, you would then need even more fuel to slow the probe down when it then got to Jupiter so that it didn't just fly past. This might look overly complicated with all of these flybys, but it's a much more efficient way of doing things, even if it is a little bit slower and you have to wait longer for the mission to get there. So from the 17th to the 22nd of August, JWST will be in continuous contact with the ground here on Earth, and every second of the way, operators will keep a very careful watch on the data coming down from JWST, just making any tiny adjustments needed to keep the spacecraft on the right course so that on the 20th of August, it'll pass just 6,807 kilometers from the surface of the Earth, crossing inside the orbits of many geostationary satellites. It's a very risky maneuver, one that no spacecraft has ever attempted before, so it's going to be really fun to follow along with all of ESA's social media channels to keep up with what's going on, especially because they're going to test all of the instruments on board JWST during the flyby as well, check what kind of data they're receiving and if they're giving us what we expect. Plus, obviously, there'll be loads of images of the moon and Earth from the flyby as well, which are going to look spectacular, which ESA have said that they'll share. Plus, there is a chance that some of you might be able to see the spacecraft as it does its flyby, just with like, an amateur telescope that you might have at home. ESA has said that so far it should be visible across the Pacific Ocean and Southeast Asia. If that changes or we get more detail from ESA nearer the time, then I'll put out a YouTube short about that. Plus, I'll report on the flyby in next month's Night Sky News for August 2024. So make sure you subscribe so you don't miss out on that. Sticking in the solar system now, let's chat about the asteroid Chiron, because there's been 2 papers come out this month studying Chiron that independently noticed it becoming a comet. Now, if you're not familiar, Chiron is sort of like a mini planet, around about 200 kilometers across, that orbits the sun in between Saturn and Uranus as part of a group of asteroids and mini planets known as the Centaurs. It was first discovered back in 1977, and ever since then, it's been a little bit of a puzzle. It seems to have rings around it, which make it a very interesting sort of planet-like object, but it still occasionally just looks like a boring lump of rock before sometimes appearing to outgas and get a halo around it in the same way that you would expect a comet to. We really don't understand still what's causing this different behavior and the changes that trigger it to start looking more like a comet. But back in 2021, astronomers at Queen's University in Belfast were searching through data from the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is a network of 4 small robotic telescopes across Hawaii, South Africa, and Chile that work together as one to scan the entire night sky to monitor asteroids and spot new ones. And in that data from ATLAS, Dobson and collaborators noticed that Chiron had all of a sudden got much brighter than normal. Question was, what caused this sudden change in Chiron's brightness? Was it something to do with the rings? Or was it a sudden burst of comet activity? Or was it just like a new side of this mini planet now facing Earth that was reflecting more light? So Dobson and collaborators used the Gemini Observatory in Hawaii to observe Chiron again to search for evidence of a halo or tail around the comet. But despite all that other data suggesting that yes, it was comet activity that they were seeing, in the Gemini image that they got, they couldn't find any evidence of a comet halo or tail. But it turns out Piniella and Alonso and collaborators also observed Chiron back in July 2023 with JWST, and they published their findings this month, which showed an extended coma with a tail made of methane. So what's really cool about these 2 results is that even though with the Gemini imaging from the ground, we couldn't spot any evidence of a comet halo, JWST from space could, which confirmed that everything else that Dobson and collaborators observed about its brightness and its phase curve that we could detect from the ground still points to comet activity as we suspected. And that means that we now, from the ground, can still look for this behavior in other mini planets and asteroids to see if we can spot this cometary activity happening from the ground and then work out what is actually causing it. Speaking of JWST, I also could not let this month's Night Sky News go by without showing this incredible new image that was released for JWST's second year anniversary of my favorite pair of interacting galaxies, ARP-142, aka the Penguin Galaxy, because these two interacting galaxies look like a penguin looking after its egg. Now, we already had an image of this system from the Hubble Space Telescope, but as usual with JWST, looking at it in the infrared, it reveals all of these new wonders, right? You can see through the dust that was there before, and also you can see this collective haze of starlight that connects the two galaxies together as they interact with each other. Now, they're about 100,000 light years or so apart. Just to give you a sense of scale, you could fit, like the entirety of our Milky Way galaxy in the space in between them. And you can see how the galaxy that makes up the penguin has been massively more affected than the egg galaxy, right? So the penguin will have been a spiral shape before this interaction, and it's just been torn and shredded apart. But from how much light we see in each galaxy, you can estimate the mass of each one, and we find that they are roughly the same mass in stars, these two galaxies. But you can see how much more compact that mass is in the egg galaxy, hence why it wasn't affected as much by the interaction. As usual, it's always fun to switch to the MIRI image from JWST, taking a much longer infrared wavelength that's sensitive to older stars and the glow from dust. And you can see how the nearby newer galaxy that's in the top right corner there with all these freshly formed stars just disappears in the MIRI image, which is so cool to see. And of course, JWST is still showing off with how many distant galaxies it detects in the background of this image that are so much further away. Perhaps in this image, we'll find a new record breaker for the most distant galaxy known so that we can add it to the list from last week's video where I went through the history of every galaxy that's ever held that title. I'll link that video in the video description below if you want to check that out. And it would mean a lot to me if you did go check it out, because personally, I think it is one of the best videos that I've made in a long time. It's my favorite anyway, so please do go check it out. And finally, we've got to talk about the intermediate mass black hole found in the Omega Centauri star cluster, because this is in the elusive mass gap of black holes. So we find a lot of black holes up to about 100 times the mass of the sun that are formed when big stars go supernova at the end of their lives, or when two black holes merge together, and we detect the gravitational waves from that merger using the LIGO and Virgo detectors. And then we find supermassive black holes at the center of each galaxy. And those can be anywhere from 1 million to tens of billion times the mass of the sun. But in the middle there, between 100 and 100,000 times the mass of the sun, we barely find anything. And that's weird, because the only way that we know of to make a black hole is from a supernova, when a star dies and runs out of fuel and its core collapses down, to make a black hole anywhere from 3 times the mass of the sun and up, to at least around about 100 times the mass of the sun. But then we find all of these supermassive black holes in the centers of galaxies, which surely have to grow from, say, 10 times the mass of the sun, all the way up to millions of times the mass of the sun, through that mass gap in the middle, and we should find loads of black holes there, but we don't. Now, there's been a few things over the years that are classed as candidate intermediate mass black holes, but usually they're like on the tail ends of those two distributions. So either you've had a merger of two already, sort of slightly massive black holes that have been made by supernova that gives you something like 150 times the mass of the sun at the end, or you found a black hole that's at the center of, say, like a dwarf galaxy that's, maybe a few 100,000 times the mass of the sun. And I've covered these discoveries before on my channel if you want to dive into the history of it all. But this month, Haberle and collaborators published this paper where they studied the Omega Centauri star cluster with the Hubble Space Telescope. Now, Omega Centauri is the most massive globular cluster of stars in our galaxy, the Milky Way, with over 10 million stars in it. It's about 17,000 light years away, but if you're in the southern hemisphere, you should be able to see it with just your naked eye. It's not far from the famous Southern Cross constellation, and you can use the 2 pointer stars to hop to it. Now, the Hubble Space Telescope has observed Omega Centauri 500 times over the past 20 years, which means that you can see the stars in the star cluster moving in that time. And so that's what Hibbeler and collaborators did. They tracked the motions of the stars in the cluster, see how they moved with time and what their speed was. And they found 7 stars moving at very high speeds near the center of the cluster. And crucially, they found that those stars' speeds were higher than what's known as the escape velocity of that star cluster. So if you look at, like how all of the 10 million stars in that cluster and you work out, okay, well, what's the mass that's there? And therefore, what's the total pull of gravity from that star cluster? You can then work out, okay, well, what speed would you need to be traveling at to have enough energy to escape the total pull of gravity of that cluster? In the same way that you can work out that rockets need to move at 11 kilometers a second to escape the pull of Earth's gravity. So for those stars to be still bound to that cluster and not to have escaped it traveling at those speeds, there has to be some extra mass in the cluster that we can't see, suggesting there's a candidate intermediate mass black hole there, which Hibbeler and collaborators estimate is 8,200 times the mass of the sun. Now, we've always suspected that if there was anywhere that we were going to find intermediate mass black holes, it was at the center of these globular clusters that we see in the Milky Way. In theory, with that many stars all in one place, you have lots of massive stars that go supernova and produce black holes that will most likely encounter each other and then merge together and then become the heaviest thing in the cluster. So slowly over time, with many interactions with other stars, they will sink to the center. So this result, along with other candidate intermediate mass black holes that have been found in other clusters over the years, is a really promising one. And it could help us understand how black holes grow from the things that are produced in supernova all the way through intermediate mass black hole and become supermassive. Now, Hibbeler and collaborators suggest that more observations by the VLT in Chile or with JWST would give you data that would allow you to work out the velocities much more accurately so that you could get a better estimate of the mass of the intermediate mass black hole there. Now, ideally, if we were going to confirm that this was actually a black hole in the center of the cluster, then we would detect X-ray emission from gas that's been superheated as it spirals around this intermediate mass black hole. But that actually depends on gas being there at the center of the cluster, which isn't likely given how globular clusters form, or at least we think they form all at the same time, all of these stars from one cloud of gas, just exhausting all of the gas that's there. So it's not like there's any leftover from the formation, and then getting gas to actually get down close enough towards the black hole, like funneling it down through the cluster, is very unlikely, just given how mind-bogglingly big space truly is. All right, that's it for Night Sky News for this month. As always, if you spot any space news stories that you want me to explain in a future Night Sky News video, then send them my way over on social media, along with any, astrophotography shots that you get of the night sky. But before we get to the bloopers, a big thank you to the sponsor of this week's video, FlexiSpot. So many of us are working from home right now, either part-time or full-time. And when we moved house recently, we wanted to make sure that both Sam and I had dedicated functional workspaces. You guys have already seen my office renovation series that I posted on YouTube Shorts, but what you haven't seen yet is that back in April, we got Sam an E7 Pro FlexiSpot desk, which is an electronic height adjustable desk. With just a press of a button, you can switch from sitting to standing, and it's so sturdy when it does it. There's no wobble at all. And what I love is that you can save those positions in the memory with enough buttons for 2 people to save their preferences as well, so me and Sam can share the desk. Now, Sam has always loved a standing desk and knew that he wanted one, but I'd always been a bit wary. I have some bone problems on my right leg, so standing for long periods of time just isn't feasible for me. So I just defaulted to getting a standard seated desk. But the thing is, sitting for long periods of time also isn't very good for our health. Particularly for me, I get a lot of stiffness in my right leg when I stand up. So I've been trying out the FlexiSpot E7 Pro the past few months, and I have to say, I am an absolute convert and now wish that I'd got one for my office as well. If I'm writing or reading, I'll sit. But if I've got like a video call with someone, I'll just switch to standing up for a while. And I found that my body feels so much better at the end of the workday just because my posture's better. My back hurts less, my leg hurts less. Plus, I get like this amazing little like focus boost anytime I switch between like sitting and standing or standing and sitting. FlexiSpot are having a sale in July with up to 50% off their products. So if you're thinking about making the switch to a sit-stand desk with all of the health benefits that comes with, check FlexiSpot out. I'll link their website in the video description down below. Thanks again to FlexiSpot for sponsoring this video. And until next time, everybody, happy stargazing. It's not just on the mornings of 30th and 31st, whereas the rest of us down to earth now and chat about what's been happening in the night sky. I still say month, so weird, but what are you gonna do? It's a very large piece of fluff, Ben. I don't know what it's there. Got it. That shape those galaxies and how's galaxies. Getting too excited. Omega Centauri star cluster. A star cluster. Escape the pull of that star cluster's gravity. Star clusters. Gravity. Too many S's. Sorry, the camera overheated and was like, I'm too hot again. So I was like, had a little bit of a chill, tie my hair up in a bun, and now it's all like curly. So people might be able to tell the difference at the end, but oh well. Oh, I thought there was like something stood on my roof peering into the skylight, like a gap. But it's just bird poo. So that's it. Anyway, this episode of Night Sky News and nope.